Right, so at this point we've gone over valence electrons, and I went over how you can figure out the number of valence electrons just by looking at the group number on the periodic table. What I want to show you now is just how ions are formed, and just looking at the periodic table, being able to figure out what side's going to give you a positive charge, what side's going to give you a negative charge. So first off, let's just go over and label where the valence electrons are going to be. So like I said before, group 1 would have one valence electron, and basically that one valence electron is saying that every element within that particular group will have one valence electron. Elements within the same groups have very similar properties, mostly because of the fact that they have the same number of valence electrons. But anyways, next group would have your two valence electrons. Groups in the middle, we're never quite sure exactly how many valence electrons those are going to have. Some have +2 at certain points, others have +3 at certain points. It just depends on what they're reacting with at the time. So those we usually ignore when we're trying to figure out valence electrons. The only ones that we really focus on are the main group elements. So let's go to group 13. Group 13 would have 3 valence electrons. 14 would have 4. Then you'd have 5, 6, 7, and 8. And as I mentioned before, all elements are trying to become like noble gases, and as you can see here, the reason why is that all noble gases, which are in that last column, have 8 electrons, and that's the number of electrons that every single element is trying to achieve. Except, again, like I said, the transition metals, they do a little bit of a different thing. Well, now that we've labeled the valence electrons on the periodic table, now we can go and try to figure out what these elements are going to do in order to be able to get the 8 electrons that they need to become like a noble gas and to achieve the octet rule. Now, there are 2 different ways that an element can achieve that goal. They can either share electrons with each other, or they can go and transfer electrons from one to the other, either by gaining electrons or by losing electrons. We're going to focus mainly on the transfer of electrons right now, and what I want to go through is just being able to figure out what an element's going to do. Wherever the location is on the periodic table, what is it going to do? Is it going to gain an electron? Is it going to lose electrons? And the periodic table is set up in such a way that you are able to figure that out. So let's say that we start off with something like sodium. So here we have sodium right here. We've already established that sodium has one valence electron within inside a shell. And now basically this element is trying to get to a noble gas. It's trying to achieve that noble gas status. Now what it can do, it has 2 different possibilities to be able to achieve this goal. It can either gain 7 electrons, so 1, 2, 3, 4, 5, 6, 7 to become like argon, or this particular element can go and lose an electron. If it lost an electron, it would become like neon. What you need to ask yourself is what would be the easiest for this element to do? What would take the least amount of energy to be able to achieve this? And the 2 choices you have is either gain 7 electrons or lose 1. Well, you're always going to go with the least number of electrons. The option that's going to give you that involves the least number of electrons. So in this case, it would be sodium losing 1. So if sodium lost an electron, it would become Na+, because of the fact that you're losing a negative charge, and you're left over with a positive one. Let's say we take something like bromine. Okay, there's bromine right there. Again, you need to figure out, what's the easiest for this to do. And like I said before, we're not looking at the middle at all. So don't even consider that right now as we're doing this. So you have bromine. Now bromine can either gain an electron, and if it gains an electron, it will become like krypton, or it can go and lose 7 electrons, 1, 2, 3, 4, 5, 6, 7, and become like argon. What's going to be the easiest? Well, in this case, it's going to be for bromine to gain an electron. So if it gains an electron, it's gaining a negative charge, so then it would be Br minus. Another example, let's say we take boron, which in this case, again, check to see what it can possibly do. It can either gain 5 and become like neon, or it can lose 1, 2, 3 and become like helium. Easiest option is to lose 3, and so it would become B plus 3. So these are just examples of how to figure out what an element's going to do. Whether it's going to gain an electron or lose an electron, it's always based on what's easiest for that particular element. So if we continue to do that with all the different groups, main group elements, what's easiest? Is it going to gain electrons? Is it going to lose electrons? We can figure out the following. For this group, it would be a positive 1, because they're all going to lose 1 electron. For the next group, positive 2, because the easiest thing for them to do is lose 2 electrons. Again, we're going to disregard the middle, coming over to group 13. This one will lose 3. For this particular row with the carbon, this row can do either or. It can either gain 4 electrons or lose 4 electrons. Usually it's not going to do either of those. It's going to actually share electrons. So that column we don't usually deal with that much because of that fact. So then going on to the next one, negative 3, negative 2, negative 1, and then 0. Again, we're figuring that out by seeing what's easier, whether it's going to be gaining or losing. From this we can actually see a pattern. If you remember, I mentioned there being a zigzag line on the periodic table, which you were able to see from the periodic table that I provided for you. And if you remember when we talked about metals and non-metals, how on the left of that zigzag line you have the metals, on the right of that zigzag line you have non-metals. So from this we can kind of determine 2 different patterns that we can actually see. First off, if you look at the left side of that zigzag line, you'll notice that all of those elements have a positive charge. And if you remember back, positive charges are known as cations. So anything to the left of that zigzag line is going to be known as a cation. And also, we figured out that to the left of the zigzag line, you have your metals. So you can conclude that on the left of that, you have metals, and those metals are forming cations. Now on the right of the zigzag line, you have all negative numbers, and those negative numbers, again, or negative charges, are known as anions. And if you remember back, anything to the right of the zigzag line is going to be a non-metal. So what we can conclude from this is that, on the right side of the periodic table, you have your anions, and those anions are non-metals. And this is especially important to know when we deal with ionic naming and actually covalent naming as well, because you need to know what side is what in order to be able to figure out the type of naming that you need to do. The last thing I want to show you is just how to go about determining from a list of ions or a list of elements and ions mixed together which one of those would have the same number of electrons overall. And you can figure that out from the periodic table, just as we have been doing. And probably the best way to do this is to show you an example. So for instance, let's say we had oxygen and fluorine and also magnesium, those 3 ions. And the question is, do those 3 ions go and have the same number of electrons, or are similar to the same noble gas? Probably the best way to do it is to go through and locate them on the periodic table. So here's your oxygen. Oxygen has negative 2 charge, so you have 1, 2. It's going to be like neon. Go to the next one, fluorine, which here's your fluorine. It has negative 1 charge. So that one also is going to be like neon. Last one is Mg plus 2. plus 2 means you're losing electrons, so you have 1, 2, and that one is also like neon. So you're just able to figure out that this list is like neon. And on the AP exam, the type of question that you might get is that, they might give you 5 different groups of elements and ions mixed together. You need to figure out which one of those groups, which group of ions is going to be equal to the same number of electrons or the same noble gas. And you would do it similar to what I just showed you. Second type of question you might get is that they might give you one ion and then give you a list of different ions and then ask you to pick the one that has the same number of electrons as the ion that they gave you. So for example, let's say you have Sr plus 2, and then for a list they give you Cl minus 1, Br minus 1, and then S minus 2. Now from that you need to figure out which one of those has the same number of electrons as the Sr plus 2. So here's the Sr. You have a positive 2, so go 1, 2. It's going to be similar to krypton. So go to your choices now. You have Cl minus 1, so here's the Cl minus 1. It's going to gain 1 electron, so it's going to be similar to argon. Bromine is right here, it has negative 1, so if it goes 1, it's going to be similar to krypton, so basically you just found your answer. But just to show you the third one, S minus 2, here's your S, go 1, 2, that one's going to be similar to argon. So in actuality, the S and the Cl are the ones that are going to be equal, in that case, and the bromine is going to be equal to the Sr plus 2. So that's just another type of question that you might get on the AP exam. So basically, we just went over how to figure out, what side of the periodic table gives you cations, which side of the periodic table gives you anions, which ones are metals, which ones are nonmetals, and also how to be able to figure out charges using valence electrons. Now, this is essential to know because of the fact that I'm not sure if in chemistry honors you were given a charge sheet for naming, but within this course and for the AP exam, you're not going to have a sheet of all the ions listed on it with their names. You're going to need to figure that out on your own. The polyatomic ions you'll probably have to memorize. The monatomic ions are the ions that form from elements on the periodic table. Those you'll be able to name easily because of the fact that you can find it all on the periodic table. And you'll be able to figure out the charges and everything else, again, right from the periodic table. So you do need to know how to do this. It might seem like an easy concept, but it is an essential concept that you need to know.